Morning to all of you. Am I audible?
Yes, sir.
Okay. So slide is visible, na? Slide is visible?
Yes, sir.
Okay. Okay. So we have started the state variable analysis. Now we'll proceed with the same chapter. So the topic is now canonical forms of state models of linear system. So how to represent a state variable and what is state variable analysis. We have taken the introductory class and we'll proceed with the next topic. Okay, that is the canonical forms, how we are representing in the state models of linear system. Now, since the state variable representation of a system is not unique, we'll have infinite ways of choosing the state variable. So this statement is very, very important. So there are numerous ways by which we can actually represent the state variable. Okay. So there is no such hard and fast rule. I have shown you some technique through which you can choose the state variable, but there is no such hard and fast rule. There are many ways by which you can choose such state variables. So we'll see that what is the actually process. So these different state variables are uniquely related to each other. So there is a correlation between the each state variables. So how this relation is established between the each state variables, we'll see that thing. So if a new set of state variables are chosen as a linear combination of the given state variable x, then we can write x equal to p into z. Okay. So let us say x is the set of state variables that is equal to p is some constant factor into z. So where P is a non-singular n cross n constant matrix, so it is a constant matrix. So here you see x equal to P into Z. So Z will be equal to P inverse into X. So that is Z equal to P inverse into X. So X dot will be equal to, so X dot equal to, so I will go to the board, then it will be easy for you. So whiteboard is visible to you? Whiteboard.
Yes, sir.
Yes, sir.
Okay. So x equal to this x equal to p into z. So z equal to p inverse into x. So x dot will be equal to p into z dot. Yes or no? If you take the first derivative of this x, so this will be x dot will be p into z dot. Okay, this statement is clear to you or not? X dot equal to p into z dot. Yes or no? This one? This is clear, na? X dot equal to p into z dot.
Z को भी differentiate कर दिए sir.
Yes, actually, what is happening, you see, you have a, let us say, y equal to 3 into x. So y dot will be what? Equal to 3. What actually we are doing? This is dy by dx equal to 3 into ddx of x, then this statement. So this is the same thing. Have you understood now? This dy by dx is written as y dot. This is y dot. And this is 3. And this is, let us say this is 3x square. For example, this is 3x square. what will happen? This is 3 into x. Okay, so what will happen? This is basically you are differentiating this thing. Okay, so both sides we are differentiating with respect to the same variable. So that's why it is x dot equal to p into z dot. Now it is clear.
Yes, sir.
Okay. Just a minute. People are now joining. Okay, fine. Okay, so we have come to this point, x dot equal to p into z dot. Okay, so now what we'll do, we'll substitute, that is ax plus bu. Okay, ax plus bu. What is that ax plus bu? Any state variable we are normally representing with the help of ax plus bu. Okay, so this is equal to az plus bu. Okay, so this is az plus bu. That means this is here, sorry, this will be ax in ax plus bu, because x is the state variable. Okay, x plus bu. So x will substitute as p into z. Okay, x will substitute as p into z. So this will be ax plus bu. Sorry, this will be ax plus bu, because this is the your state variable. So ax plus bu. Now x equal to, we know this is p into z. This is x equal to p into z plus b into u. So this is your pz dot. This is equal to x dot equal to pz dot. So that means this is pz dot. So z dot equal to this pp will cancel. So this will be something, some other constant a into z, and this will be b bar into u. So this is the representation of the canonical form. This is the representation of canonical form, representation of state variable. Is it clear? Okay. Is it clear? Should I explain once again? Hello? Hello?
Yes, sir. Please explain once again.
Okay, no issue. So first we know this x equal to p into z. So z equal to p inverse x. Now x dot, we are differentiating this thing with respect to x, both sides. So this will be x dot equal to p into z dot. Now here you see, this we are representing as ax plus bu, ax plus bu. Okay, this one we are representing ax plus bu. Now here you see ax plus bu. So this one is what? This one is your p into z dot, because this is x dot equal to, we have written ax plus bu. Now p into z dot equal to a into x, we have written this is p into z. So this is p into z plus b into u. Now z dot equal to this, z dot equal to this p, we are cancelling. Basically both sides we are cancelling this p. So what will happen? This whole term is divided by p. So this becomes a bar into z. Means basically it is a bar equal to a. But we are representing with the help of a bar. And this will be what? This is b by p. So b by p we are writing as b bar into u. So this is the basically representation of the canonical form. Now it is clear.
Yes, sir.
Okay, fine. Now next topic is the phase variable form. This is something different than what we have represented in the canonical form. Now, the phase variable form, it is when one of the variables in the physical system and its derivatives are chosen as state variables, then the state model obtained is known to be in the phase variable form. So, what is the kind of thing? Let us say you have a state variable x. Okay. Now, the derivative of the state variable is basically x dot. Now, x dot is taken some state variable. Now, x dot equal to something we have assumed. Let us say x dot equal to, we are assuming x1. So, and then x1 dot equal to, we are assuming x2. So, consequently, the derivative of any state variable is assigned some other state variable. Okay, we'll see that thing. So, the method, this is the phase variable form method. So, how we'll do this thing, we'll understand gradually. Now, the state variables are themselves known as phase variables. So, here the name, the state variable, in this case, it is known as the phase variable. Usually, the output of the system and its derivatives are chosen as the state variable. So, this is the beautiful thing. The output of any system and its derivative, both are chosen as the state variables. Now, we'll derive the state model when the system is described either in differential equation form or in transfer function form. So, both the cases, this kind of representation will be applicable. Either if the mathematical equation is written in differential form or in transfer function. So, let us consider, let us understand how this thing is coming. A general nth order differential equation, it is given by y to the power n plus a1 into y to the power n minus 1. Yn means what? It is yn means nth order derivative. It is yn is basically dny by dtn. This is the nth order derivative. This is not y to the power of n. It is yn. It is written at the cap, at the top of this variable. That means that is the order of the variable, means the order of derivatives of that particular variable. So, plus any, y dot means this is the first derivative, dy by dt, plus any equal to v0 into um. So, these are the output, these are the multiple output, and these are your input. So, b0 into u to the power m means um means this is the mth order derivative. This is dmu by dtm. This is the mth order derivative. Plus b1 u to the power m minus 1 plus bm minus 1 u dot plus bmu. So, this is the basically form where a general differential, nth order differential equation is represented. Now, these aj and bj, these are basically constants, and these are basically m and n are the integers with n greater than m. So, n greater than m means, try to understand this, n is greater than m. So, that means output, the order of the output, that means number of output present is greater than the input. So, the n initial conditions for all these cases, it is assumed to be 0. So, because here we are assuming that all these initial conditions are assumed to be 0. Now, how we can, if let us say this is the transfer function, this is the differential equation is given, how to convert this differential equation into transfer function. This is the basically task what we are actually going to execute. Okay. So, let us say this is the, so I will just, this thing I will draw in the board so that you can understand this thing. Okay. So, anybody just take this snapshot of this particular equation so that you will just help me to write this equation when I will write in the board. Take this snapshot of this particular slide. Okay, and help me that what are the coefficients. When I'll ask you, you just tell me. Have you taken the snapshot of this thing?
Yes, sir.
Okay, so I will go to the board. So please help me at that time because the coefficient will be required. Okay, please tell me what is the equation? What is the equation? That is y to the power of m. Mth order. This is nth order. This is yn. Please tell me the equation. What is that equation?
Y to the power n.
Yes, plus this is a1. This is a1.
A1 into y to the power n minus 1.
Correct. This is then an minus 1 y to the power plus, please tell me what is that?
y to the ऊपर डॉट है सर, डिफरेंट वो है मतलब
Dot, correct. Then this is next plus a to the power, a n,
y,
correct. Then equal to, this is b0 into u,
u to the power m,
u to the power m, b1 u to the power m minus 1, and this is your, what is this? Last term is b to the power m minus 1 u dot. Yes or no? Just check your from your.
yes sir, yes sir, yes sir, yes.
This is bm and this is u. Is it correct?
Yes sir, it is correct.
Okay. So now you see how to convert this thing into your transfer function. So here this y to the power yn, this is actually d2 dn y by dtn. Okay, this is the nth order. Similarly, yn minus 1, this is equal to basically dn minus 1 y dtn minus 1. Okay, dtn minus 1. Similarly, y dot, this is equal to, try to understand what is this thing actually, dy by dt. Okay, similarly here I will just explain u to the power n. This is actually dm u by d to the power n. Then um minus 1. This is dm minus 1 u by dt m minus 1. And this is u dot equal to, this is du by dt. Okay. So this is the actually what is given in this equation. In short, it is basically represented with the help of dot, okay, or some coefficient. So now let us say for this differential equation, we know all these differential equations, they are having some initial value. So all initial conditions are assumed to be 0. So there is no question of the initial condition, because if you take the Laplace, then what will happen? There is a question of what is the initial condition. But for this problem, we are assuming that all the initial conditions are assumed to be 0. So now we'll taking Laplace transform. Taking Laplace transform of, let us say, this is your equation 1. Of equation 1. Okay. So what will happen? You see, y to the power n, this is basically your, this will be s. We are representing with the help of s. So this will be s to the power n plus a1. S to the power n minus 1 plus dot dot a n minus 1. This is basically your s plus a n. Okay, because dy by dt, when we are representing with the help of your Laplace domain, this will be only s, because only this ddt, this ddt, this is your a single power of s. Okay, next this will be b0 s to the power m plus b1 s to the power m minus 1 plus dot dot bm minus 1 s plus, this will be your bm. So this is bm. Yes or no? Any doubt from anyone? Any doubt? So this will be actually your, this coefficient will be multiplied by ys, and this will be multiplied by us. Any doubt from anyone? So ys by us, output by input. Ys is the output, Laplace transform output. So this will be equal to b0 s to the power m plus b1 s to the power m minus 1, and this will continue. So this will be plus bm minus 1 s plus bm divided by, this will be s to the power n plus a1 s to the power n minus 1 plus an minus 1 plus s plus a to the power n. Any question from anyone? Please, if you have any question, please tell me. If you have any question on this particular derivation, please tell me. Anyone? Actually, you have not understood this thing, so please tell me. Do you have any question? So this is the representation of any differential equation. If it is, you have to represent in transfer function form. This is basically what we have represented, that is in transfer function. Okay. So you see this thing, actually we have derived this equation. This Ts equal to this transfer function ys by us equal to b0 s to the power n plus b1 s to the power n minus 1 plus dot dot plus bn divided by s to the power n plus a1 s to the power n minus 1 plus n. Okay. So that means if any differential equation, if it is given to you, then you will be able to convert that differential equation into transfer function form. So if you have understood, then tell me yes. If you have not understood, then tell me that, please. I will just explain that particular portion. Hello.
Yes, sir.
Okay. So why you are keeping your this means I don't know what is happening to you. You are too much thinking that if I tell that yes, then sir will tell something. So you have to tell me that if you are understanding, then you tell yes. If you have some problem, then you tell this, sir, please repeat this thing, so that I can actually repeat that particular portion, so that you can understand it. Okay, fine. Now let us say the cases, this first is m equal to 0. So what will happen when m equal to 0? So let us say this m equal to 0 means this is your, all this term will vanish. So this will be u to the power 0 means 1. So that means there is a single input and there are multiple input. Yes or no? Have you understood this concept? If m equal to 0, m equal to 0 means there is only b0 into u will be there. So that means there is a single input and all these outputs are there. So there is a particular system, a particular system is there where there is a one input is present and there are multiple outputs are taken from that particular input. So that governing equation is that this is the left side is same and right side will be equal to your v0 into u. So now we'll see this thing. So now let us say this is what will happen. This is y to yn plus a1 yn minus 1 plus dot dot an minus 1 y dot plus an y equal to b0 into u, because m equal to 0. The right side term, all these terms will be equal to 1. So that's why it is b0 into u. Now let us define the state variables. So we'll now define, we'll solve these particular differential equations. See, last derivation we have seen that how to convert a differential equation into transfer function form. So you just try to understand what we have just now we have derived, that is how to represent a differential equation into state variable into transfer function form. Now we'll understand how a differential equation, if it is given, so how that differential equation can be represented with the help of state variable. Okay, so we'll understand this thing. So let us say we are assuming that a state variable x1 equal to y. So we have assumed that thing. Now x2, again we are assuming x2 equal to x1 dot. So x2 equal to, we are assuming x1 dot. So x1 dot equal to basically y. Now another state variables we are representing, that is x3 dot, x3 equal to x2 dot. So x2 dot equal to basically your y double dot. And if you proceed this way, And finally xn will be equal to x dot n minus 1. So you see the state variable we are taking, the next state variable will be the derivative which is taken in the earlier step. So this will be x dot n minus 1. This will be equal to y n minus 1. So finally x dot n will be equal to finally this is equal to yn. So if we represent this thing, so let us say we'll go to the board and we'll write this equation so that you can understand this thing clearly. Now take this snapshot of this particular thing, this particular equation. Have you taken the snapshot?
Yes, sir.
Okay, fine.
Yes, sir. Taken.
Okay, fine. Now you tell me what is that first equation, that is this is yn plus a1 into yn minus 1 plus dot dot an minus 1. This will be what? Y dot, okay, plus a0 into y equal to b0 into u. Yes or no? Or any change in the equation, any coefficient?
So A and Y now.
A and y. Okay, sorry. Correct. A and y. Any changes in the other thing? Otherwise, this is correct.
Yes, sir.
Okay. Just I will erase this. So this is basically your A and y. Correct. Now see, we'll choose the state variable. How to choose the state variable? How to choose state variables. So first we'll assume that x1 equal to, we are assuming this is x1 equal to something y. Okay. Now x2 is the another state variable which is taken as x1 dot. So this will be obviously y dot. Then x3 is another state variable which is chosen as x2 dot. So obviously this will be equal to y double dot. And this way it will proceed. Okay. So xn minus 1, this will be equal to what? This will be what? This will be xn minus 2 dot. Okay. And this will be your n minus 2 dot, okay, or this will be actually n minus 2, okay. Then xn will be equal to xn minus 1. This will be equal to yn minus 1 dot, and this is xn dot equal to yn. Okay, this is clear.
Yes, sir.
Any doubt from anyone? Okay, so now what we'll do, this is yn. Okay, so yn equal to b0u minus a1 y to the power of n minus 1 minus all this minus n1 y dot minus ny. So what will happen? We'll substitute this thing. So this is your b0 u, yn equal to what? This is your xn dot. Okay, minus a1, yn minus 1 is what? Yn minus 1. This is equal to your xn. So this way it will continue minus n minus 1. So this is y dot. Okay, so this is an minus 1 y dot means what? This is equal to x1 dot. This is x1 dot and an y. So y is x1. So this is an x1. Is it correct or not? This one? Okay. Clear? Any doubt on this equation? Any doubt? Okay.
Yes, sir.
Okay. Fine. So just you tell me this thing again. I require this equation. So here I think we can do this thing. Just a minute. So we'll choose all these variables, x1, x2, x3, up to xn. So this is x1 dot, x2 dot, x3 dot, this is xn dot. This is a matrix. This is a matrix. Or could you please tell me this equation? Some of you just copy this equation, only this portion I require. This portion. Have you copied it somewhere? So please tell me when I will write this equation. Okay. Have you copied this xn dot equal to b0u minus a1 x1 xn? Okay. So you see this thing actually whatever we have done here, b0u minus a1 xn minus a2 xn minus 1 minus n1 n minus 1 x2 minus n x1. Okay. Okay. So next slide I will go. So what is the equation? Xn dot equal to, please tell me. What is that?
So B not U
Just a minute. Huh? B naught U
minus A1
A1
XN.
XN
तो फिर जाते जाएगा तो फिर आ जाएगा डॉट डॉट फिर माइनस ऑफ A n
A
minus 1
A
n minus n
N
minus 1
uh,
x1 dot x1 dot
X1 dot equal to, we can write X2. X1 dot equal to X2. Then minus
of A and x1.
N X1. Correct. Okay. Very good. So here we'll write that all state variables. Okay. Now we'll write. So this is equal to X1 dot, X2 dot, X3 dot, and dot dot up to Xn dot. So this is equal to what will happen, these equations. So these are all state variables basically. These are x1, x2. We'll basically write in the form of x dot equal to ax plus b into u. We'll write in this form. This is your xn plus the B matrix into your U. So U is only there, a single U. Okay, so this will be 0, 0, 0 up to lastly there will be U. Okay. Now here you see, you just tell me, first of all, if you just understand that x1 dot equal to what? X1 dot equal to x2? Yes or no? X1 dot equal to x2. If you just see the how we have chosen the state variables.
Yes, sir.
X1 dot equal to x2. Yes or no? Okay. So here you see this will be x2 is here. So this will be 0, 1, then 0 dot 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 0. Yes or no? Then x2 dot equal to your x3. X2 dot equal to x3. So what will happen? X2 dot, this is in third term. So this will be 0, 0, 1, and this will be all remaining terms will be 0. Then if you see X3 dot equal to X4, what will happen? X4 is then the fourth term. So this fourth term means this will be 0, 0, 0, 1. This is 0. So this way it will continue. Now lastly we have minus A1 xn. Okay. So first if you see this term is n. Okay. Minus n x1. So x1 is at the beginning. Okay. First state variable. So this will be multiplied with this in the matrix multiplication. So this will be minus n. Then this will be minus an minus 1, and this will continue till it reaches, this is xn into minus a1. So xn is at the last. So this will be minus a1. Okay. So now this is b0 into u. So b0 into u means obviously this last term will be b0. So b0 into u. And all these remaining terms will be equal to your 0. So this is the form, that is x dot equal to ax plus bu. So this is the basically a representation in phase variable form. Any doubt from anyone? Please tell me. If you have any doubt, please tell me. I will repeat that portion. No issue. समझ में आया बेटा सबको?
Yes, sir.
If anybody has any doubt, please tell me, because ultimately you are supposed to solve the numerical problem later on. These are basically theoretical part. Okay, so this way actually we are going to represent. So here it is written. So unless and until I will explain it in the board, so you cannot understand. That's why I have actually represented in this thing in the board. So the output is equal to, then output is represented in the form of y equal to c into x, where c equal to 1, 0, 0. So this is basically your row matrix. This is row matrix, and this will be your column matrix, x1 to xn. Okay, because c anyhow it is in the row, and x will be, all these vectors will be basically the state variables will be in the column vector. Okay. Now, if the transfer function is known instead of differential equation, we can easily obtain a differential form as shown below. So let us say the reverse is also possible. Sometimes a transfer function will be given to you, but you need to derive it in the differential equation form. Okay. So this is the reverse thing. So first, today what we have discussed, how to convert a differential equation into transfer function form, that we have derived this thing. Then if a differential equation is given, how to convert that particular differential equation into phase variable form. That means how to choose the state variable, how we can write those state variables. Okay, so that part we have discussed. And now next thing is, if a transfer function is given, we need to convert this particular transfer function into differential equation. So that is very easy compared with the previous one. So let us say m equal to 0. That means that the first case, okay, the only single input, okay, single input and multiple output. This one, this is yn plus a1 yn minus 1 plus an minus 1 y dot plus an y equal to b0 into u. Single input, multiple output. So this is the equation. Same equation we are using here. So we know that transfer function Ts equal to, we have derived this transfer function. Just now we have derived this transfer function. So if we just take that transfer function and then we convert this into differential equation, so what you are going to do? So s to the power n, what we will do? This is ys. So obviously this will be nth order derivative. Simply it is very easy. If it is s to the power n into ys, that means this ys variable, it is nth order. So nth order derivatives will be there. This is yn t plus a1 yn minus 1. So s to the power n minus 1 into ys. So that means this ys y variable, this is n minus 1th order. So this is a1 yn minus 1. Like that, plus an ys. So an ys means this is an y and equal to b0 into us. So this is basically b0 into u. because you anyway it will be b0 into u. Any doubt on this part? If a, let us say, a Laplace, basically a transfer function is given, how to convert that transfer function into differential equation? Any doubt from anyone? Any student? Any doubt? You have doubt or you have understood?
Yes, sir.
Yes, sir.
Okay. So here you see, this is actually representation in block diagram form. It is again, just I will repeat this thing. So the same differential equation, how we can represent in block diagram form. So just try to understand this thing. Here the equation is basically b0 into u. Okay, b0 into u. What we'll do, u is there, that is the input, and a constant block we are taking. So this output will be b0 into u. Okay, that is basically your positive input. Now you see b0 into u. This is minus a and y. This, if you are taking this one, this side, a and y. So minus a and y. So you see y is the output. You will take output y. Then a and y. So a and y is coming here. Okay, we are adding all these things, then we will add here. So this is a and y. Then what will happen, you see? N minus 1 y. Okay, so this is basically a integrator is there. Then we have a n minus 1 y, and this will continue. Okay, then you have a c. You have something a1 into yn minus 1. So a1 into yn minus 1 means this is basically your xn. Okay, this is your xn. So xn will come here, and finally this is, if you integrate xn dot, so all this term is coming here. So this summation is going here. So that means basically what we have done, I have just shown you that this equation you see. This is xn dot equal to b0 u minus a1 xn minus a2 xn minus 1 an minus 1 x2 minus an x1. So this thing we have written here. This thing actually, this is an x1. Then this integrator means what? This term is basically your, this term xn minus 1, xn minus 1. If you integrate this thing, basically this is your x1 dot. So if you integrate this thing, this will be x1. Because anyway, if you, this is x1 dot means what? X1 dot is basically dx1 by dt. So dx1 by dt, if you integrate this thing, this only x1 will come. Okay. So all these terms are added here, and this is, as this together will go to the input as negative input. Then this is equal to basically your xn dot. So xn dot is your input, xn dot is your input. So xn dot equal to b0 u minus of all these things. So this is, that's what we have written here, xn dot equal to b0 u minus this. So this is the representation in block diagram form. Okay, we'll have some a numerical example. Okay, we'll have to do this thing, numerical example. So obtain the phase variable state model of the system y double dot equal to 2y double dot plus 3y dot plus y equal to u. Okay, so this is the state variable form which is written. Okay, so please try to solve this problem. All of you, please try to solve this problem. Similar way, just now we have represented this thing. This is the actually form. This is nth order, but it is basically in the second order. Y double dot plus 2y double dot plus 3y dot plus y equal to u. Please try to solve this thing. What you will do? How will start this thing? Huh? I will start what we have done here. X1 equal to y. So similarly, you will start here. X1 equal to y. Yes or no? So x1 equal to y. So x2 equal to x1 dot. This is equal to y dot. And x3 equal to x2 dot equal to x1 double dot. This is equal to y double dot. So what is the equation given? Y double dot plus 2y double dot. Yes or no?
Yes, sir.
Plus, what is
Plus
that?
3.
3
Y dot plus
y plus y equal to
U.
U.
equal to u. So this will be 3y double dot plus 3y dot plus y equal to u. So you see 3y double dot. Okay. So now you just try to solve this thing. So this is your y double dot. So this is your, what is this? This is 3, and then this is 2y dot. These two things are actually given. Okay, fine. Y double dot equal to your 3x3, and y dot equal to what? 3x2 plus y equal to what? This is x1 equal to u. So in state variable form, this will be, I think this is triple dot. By mistake it is written. Correct it. Please correct it. This is y triple dot. Okay. This is y triple dot. Okay. Just you correct. Otherwise, this will be incorrect. So this will be y triple dot means x4. This is x3 dot equal to y triple dot. Okay. So basically this will be x3 dot plus, this will be 2x3 plus 3x2 y equal to x1 equal to u. So this will be x3 dot x2 dot plus x1 dot. So this is equal to your x1, x2, x3, and this is your, this matrix. This is u. Anyway, this is 0, 0, u. And anyway, this will be 0, 0, 1. This will be 0, 0, 1. So what is this? x3 dot equal to what? x3 dot equal to x3 dot. x3 dot equal to what?
Y double dot.
Y double dot. Okay, correct. Sorry, I have taken this way actually. This is first x1, x2, x3. So this will be x1 dot, then x2 dot, and then this will be x3 dot. Okay, so x1 dot equal to what? x2. x1 dot equal to x2. Okay, so x2 is what? This will be second term. So this will be 0, 1, 0. Then what is x2 dot? x2 dot equal to your x3. So x2 dot equal to x3 means this is third term. This is 0, 0, 1. And this x3 dot equal to what? x3 dot equal to your y double dot. Okay. So this will be equal to your, this will be equal to means,
Sir, Y triple dot.
Y triple dot, correct. This is Y triple dot. So this will be equal to your X3 dot is not there. So this will be equal to your 0, 0, 0. Okay. So this way we have to proceed.
सर ऊपर से y3 डॉट का वैल्यू नहीं निकाल सकते हैं
From where?
सर वो जो इक्वेशन लिखा हुआ है y ट्रिपल डॉट प्लस 2y डबल डॉट प्लस 3y डॉट
Correct. 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 From here we can write. This is you want to mean this thing. Y triple dot equal to u minus 2y double dot minus 3y dot minus y. Do you want?
यस सर
Yes, we can do. Same thing we'll get. Okay. Any doubt from anyone? Any doubt?
नो
Okay. So we'll stop here this thing. We'll take your attendance. Just a minute. But try to solve this problem from your own. Because if you are not solving, then you will face difficulty. I will give you some of the numerical example. Okay, thank you. So Monday onward, you have this time a different kind of exam. Have you? Do you know this thing that this time you have to write in a paper? All of you are aware of this thing?
Yes, sir.
यस
Okay, so your video camera will be on and your teacher will sit and teacher in front of the teacher, you are supposed to write your exam. Okay, so please be prepared for that and do well in this exam. Okay, because anyway from Monday there will be exam. Okay, so thank you. We'll meet.
सर आपका क्या पोर्शन रहेगा
From my portion, yes, it should be clear to all of you. Last chapter, what was the last chapter I have covered? Last chapter?
सर रूट लोकस
Root locus. Okay. So root locus, and then I have discussed Routh-Hurwitz, and this is the state variable is the third one, no?
यस सर
Yes, sir.
Okay. So root locus and Routh-Hurwitz, both the things will be there. And okay, these two chapters. These two chapters. Okay. Okay. Thank you. We'll close this meeting.
थैंक यू सर